Hello everybody, I am Vijay Apte from Empower Tutorials. Today we are going to consider some specific problems on complementary angles for 9th standard and trigonometric identity problems for 10th standard. So the first problem is on complementary angles, cos 22 upon sin 68. I am writing first problem here, that is cos 22 upon sine 68. Whenever the problems on complementary angles you have to solve, you check whether the division contains co-ratio or not. Now I will write down co-ratios. Co-ratio for sine is cos, then sec is cosec, and cot is tan. Clearly here in numerator there is cos 22 and denominator sine. So these two are co-ratios. So we can write cos 22 upon sine of 90 minus 22 by using the identity sine theta is equal to cos of 90 minus theta, or cos theta is equal to sine of 90 minus theta. What I am doing, I am expressing sine 68 as sine of 90 minus 22. Sine of 90 minus theta is cos theta. My theta is 22. So I can write cos 22 upon cos 22. Clearly this can be cut off and the answer is 1. So this is our first problem. Students, you have to only remember that whenever there is a division on complementary angles, the trigonometric ratio must be in the form of co-ratios. That is, co-ratio of sine is cos, sec is cosec, and cot is tan. I hope this is understood to you. We will consider the second problem that I am going to write. We have to prove that sine of a plus b upon 2 is equal to cos c by 2. If you read problem very carefully, that it is a triangle. ABC are the angles of the triangle. So I can write A plus B plus C is equal to 180. That is the angle sum property of a triangle. Now on left hand side I want A plus B. So I would shift C on that side. So it will become 180 minus C. And then what I will do, I will divide the entire thing by 2. So it will become A plus B upon 2 is equal to 180 minus C upon 2. And then I will take sine of both things. So it will become sine of A plus B upon 2 is equal to sine of 180 minus C upon 2. Now here 2 is in denominator. So you have to distribute this 2 to both. So it will become sine of 180 upon 2 minus C by 2. Clearly 180 upon 2 will become 90 minus C by 2. That is, on left hand side we have to copy down this, that is A plus B upon 2. And by the formulae, complementary angles formulae, we can write it as sine of 90 minus theta is cos theta. So this is nothing but RHS what I got. I think so you understood this. We will solve, these are the problems on complementary angles 9th standard, and now we will consider some 10th standard problem on trigonometric identities. I will write down the problem. Under root of 1 minus sine theta upon 1 plus sine theta and I have to prove it as sec theta minus tan theta. Whenever such root problems come, in 90% cases, you have to divide by the conjugate of denominator. So what is the conjugate of denominator? That would be 1 minus sine theta upon 1 minus sine theta into 1 plus sine theta. In numerator, you can see that it is a minus b into a plus b. So it can be written as a minus b whole square, and denominator you have to apply the formula, that is a plus b into a minus b, that is a square minus b square. Clearly 1 minus sine square theta is cos square theta. So I can write this as 1 minus sine theta whole square upon cos square theta. Now next step is that I can write entire thing as 1 minus sine theta upon cos theta whole square. Now what mistake student do is that they expand this bracket. So instead, don't expand this bracket, just write it in terms of whole square. The square root and square will get cut off. So you will get 1 minus sine theta upon cos theta. Then by using the law of algebra, that is a plus b upon c can be written as a upon c plus b upon c. I can distribute this cos theta to both. So it can be written as 1 by cos theta minus sine theta upon cos theta, which can be written as sec theta minus tan theta, which is nothing but RHS. I hope this problem is understood to you. Please subscribe our channel. Thank you very much.